Yeah, I'm Amogh Desai, and I'm working as a software engineer in the CDE team. And I have my teammates Rohit and Tarun, who are joining via Zoom, and Satya is right here with me. So, so the agenda for my presentation is that I'll be giving a quick introduction of Cloudera Data Engineering and what it means. Then I want to touch upon how Airflow powers CDE or Cloudera Data Engineering. Then I'll be, if there are no hiccups, I'll be giving a live demo, and I'll also be touching what we are working on currently with respect to Airflow in CD. So yeah, let me start with the quick introduction of CD. So yeah, before we know what CD is, we need to know something about what CDP or Cloudera Data Platform stands for. So the focus of Cloudera Data Platform is to manage and do a bunch of stuff with data. So now as you can see in the bottommost layer that we support multiple infrastructures which involve public cloud. So that involves AWS, Azure, etc. And private cloud, which involves OpenShift distribution and Rancher distribution, etc. And we are also doing public multi-cloud and hybrid cloud these days. So on top of that, we have a model where we try to support data in anywhere kind of model in terms of something known as SDX, which stands for Shared Data Experience. So SDX is a fundamental part of the Cloudera data platform architecture, which is independent from the storage and compute layers, and it delivers a set of security and governance practices into the product. So this is agnostic of the type of the cloud, and we try to deliver these analytics across public and private clouds. So we build a few analytic experiences on top of the infra and the data anywhere model. And what we are trying to do here is we are trying to deliver CDP as a one-stop solution for all your data needs. So the aim is that we want you to do anything and everything with data. For example, we want you to bring in data via data flow and streaming, then do some ad hoc processing using data engineering, then perform some analytics using data warehouse, and finally build some machine learning models and train and test them on this data. So all this is achieved by a centralized control plane, which is purely managed by Cloudera, and it's a web service which is hosted and managed by Cloudera, and we provide a management console with features like identity, orchestration, management, and operations. So yeah, during when we were starting Cloudera Data Engineering, we went through some of data engineers' pains. So the studies reveal that the data engineers' pain points lie in one of these regions. So before he starts, he has to start a deployment, which is spinning up clusters, adding and managing capacity and artifacts, which is hard and time consuming. Once he has the deployment in place, he will have to make sure his resources are isolated so that the workloads don't compete with the other workloads in the same cluster, causing SLA misses. Then after you have the resource isolation and deployment in place, you will have to have some visibility into your resources and deployment, which is where you'll have to have some monitoring pipelines. You will have to troubleshoot the failed jobs and data validation, which is challenging. And you'll have to do all these things while keeping security and lineage practices in mind, because managing access to stuff is critical. So moving on, with this in mind, we came up with Cloudera Data Engineering. So what you see on top, what you see here is the general life cycle in a data pipeline. So this is how a customer works. So they write some code, then they start to operate on it. The operation involves testing the code. If all looks okay there, then they deploy it. Then maybe they want to run it at regular intervals. This is where we use Airflow to schedule the workloads. And eventually, once you do that, you will have to monitor your runs for results. So we do all this by providing a certain ecosystem. So we have a rich job management API support and a profiler in place uh, through which you can access Apache Spark and Airflow, and you can run their workloads on an auto-scaled Kubernetes cluster. So we also have so we manage the scheduling using Apache Unicorn. So here you can notice that most of the components, if not all, are open sourced. So we use Apache Spark, we use Airflow, we use Kubernetes, and Apache Unicorn as well. So yeah, so these are some details regarding CDE. So yeah, the CDE experience is again built on top of the same shared data experience which we discussed when I was introducing CDP. So on top of it, we support a Spark runtime. So we are essentially running Spark on Kubernetes here. Then all these features come with platform operations support like auto scaling. Then you can provision your entire cluster with a single click. We have everything in a containerized and isolated manner. We have rich monitoring using Grafana Prometheus, and we also do a multi-version support. We on top of the platform and the Spark runtime is where we build our job management system. This is where we support features such as dependency management. We have self-service troubleshooting using DAG bundles. We have automatic lineages, and we can do job management and scheduling using Airflow. So all these features are available in three forms to provide a seamless integration based on the customer requirements. So we have a support for a web UI, which is very detailed for those of you who want to use the web interface for being able to interact with the product. Then we have a command line interface also in place. And for those of you who are a little old school and don't want to install anything, we have a rich API support as well. So yeah, coming to the main question now, since we have set a baseline, how does Airflow power CD, right? So before jumping to that, one question that arises is why did we choose Airflow in the first place? So based on Pankaj and Eric's introduction, we can clearly tell that Airflow is something that is going to be there, and it's the next generation orchestration tool. And it's an integrated and purpose built specifically for data engineers. So a few advantages what we saw when we were integrating was we can simplify pipelines a lot. So we are able to construct really complex pipelines using very simple baby steps. It's very easy to diagnose and optimize the DAGs. And since everything is modular, we can modularize stuff and we can increase the reusability. It also has a very open nature where it is preferred tooling for most data engineer and machine learning practitioners. There are already hundreds of existing operators present. So you can do a lot of tasks using so you can do a lot of tasks using these hundreds of these existing operators. If you still feel that I need something more, you can write your own custom operators and you can work with it. And Airflow, as explained by Pankaj and Eric, it has a very strong community footprint. So you can expect a lot of great community support from for your questions or for the support. Then we also have one more point we kept in consideration was the integrated life cycle. So there is an out-of-box integration with Cloudera Data Platform, and you also have the flexibility to run both Spark and Hive jobs. And currently, we are also making it extendable to other Cloudera Data Platform endpoints. So yeah, to summarize how Airflow powers CD, so CD enables a single-click bringing up of virtual cluster, and virtual clusters are the basic compute units where you can run your workloads and jobs. So data engineers can run Spark jobs, Python jobs, and Airflow based pipelines within a virtual cluster. There is absolutely no need to deploy and manage Airflow yourselves. CDE will do that for you. You can schedule any job, the ones that I mentioned earlier, using Airflow. And currently, we're following a cron or time-based scheduling so that you have a very finer-grained control over your schedules. And you can create really complex pipelines with very simple steps. Yeah, coming to the structure here, a very basic architecture of where Airflow fits in. So when you sign up for a subscription of CDP, so we have a Cloudera managed control plane for you, and this control plane has the power to perform CRUD operations with respect to clusters in your cloud budget or account. So once you sign up and you decide that you want a few clusters in place in your cloud account, that is where that is where the control plane will install it will install some infrastructure services which involve things like cluster provisioner, which has control of provisioning virtual clusters and managing them. We have a DAG and monitoring service here, and we use Apache Unicorn as the first class Kubernetes scheduler. So when you sign up and create a CD service, and CD service is basically a cluster where your compute will be there. So it creates an auto-scaled Kubernetes cluster which will scale up or down based on the load and the usage. And as I mentioned earlier, virtual clusters are the compute units where workloads or jobs can be run. So you can create multiple virtual clusters within a single CD service, and this is where the magic happens. You can choose to run Apache Airflow, Apache Spark jobs. You can create complex pipelines, and everything will run within the scope of this particular virtual cluster. So yeah, coming to DAGs now, you can create the simple DAGs using the operators that are already present upstream. But if you want to do something a little custom to your use case, you can see that most Airflow operators are already defined in open source. But when you want to do something little custom or out of the box, that is where Cloudera provides support to orchestrate 4 kinds of tasks in your DAGs. So you can have support for Hive, Spark, Python, and Bash scripts, all as tasks in your DAG. So we also have some CDP providers and operators for easing this process for you. So we have a CD job run operator, which is how you can create and run Spark tasks. And we have a CDW job run operator, which is again used for it abstracts out the Hive task cases. So just to cite an example, I have a very simple DAG here with 3 tasks pointing upstream to another one. So these 3 dark blue boxes are, as you can see, it's CD job run operators. And these do some processing on the data, some ad hoc processing, and it's eventually passed on to a CDW operator, which is the Hive operator, maybe for storage purposes. So I have also tagged a link here, which is where we have our custom operators defined. You can, interested ones can have a look here. So moving on to the live demo now. So when you try to when you go to CDP, this is the landing page that you observe. So from here, what we are interested in is data engineering. I think there was a lag, but so here we have a few services defined, and as mentioned, the virtual clusters. So I'll just go to one of those now. So I've already kept one open. So here you can go ahead and create jobs, your Airflow jobs. So I have, when we load up this, when we spin up this cluster, we have some example jobs created for people to try out. So similarly, we have an Airflow job created here. So if you check it out, you can, we have also embedded a Airflow UI within the UI for ease. So this is a really simple tag with just two tasks. So we have a basic ingest step, and we have a preparation step, and we are just linking them upstream with each other. And you can choose to run it from here. You can go to actions and run it. This is where a job run will be created. And yeah, it will perform the tasks for you. You can see the logs here. You can check the configuration and the UI as well. So, so in the UI, you can check the active tags here. You can, as Pankaj had shown a demo, or you can see the success running and all these things. If you want to go inside one and see the usual steps to it, you can see a tree view, a graph view, and yeah, so on and so forth, which is running and basically what is happening here. But there might be for this kind of model, you need to have you need to write code. You need to write a DAG file and you have to upload it, and that is where we'll run it. But we also have a drag and drop kind of approach where you don't have to write any code, and you can just drag and drop a few operators around. So if you go here and let's create a live DAG now, just call it editor Airflow job. I select editor and I say create. I'll do that again. Yeah, so this opens up an editor for you. So here you can, as I mentioned earlier, we have 4 kinds of operators in place. So we can drag and drop a few of them. So let's take a CD job one, and let's select a simple scale up here. So I will then want to maybe link it to a shell script. So I'll bash terminal opens here, so I can just have a simple hello here. Then I can maybe save it. And to have a little more complex structure, let's pull one more shell here. Let's again do some echo here. And we can have, to wind it all up, let's have another CD job, which is a simple scale up again. And now we can create links between them. Can link these two, then we link these two, and can go in this way. Yeah, and just save and run it. Okay, so the pipeline has been submitted, and if you go to job runs, you can see a job that has been launched. So if you want to see what it looks like, right, go back to the Airflow UI, and yeah, these are the tasks, and check out the Airflow editor Airflow job. So here you can see that, yeah, let's go to the graph view. Yeah, this is what we created. So this DAG has been launched now. It is, yeah, it's in a yet to run state, but yeah, it will run. If you go to the code part of it, you can see that the code was auto-generated. You didn't have to write any code, and you can see that, yeah, we had a CD job run followed by a bash, and then a CD job run operator to end it all up. So yeah, this is how it is being linked also.
Is it using Celery or Kubernetes?
The default running is Kubernetes. Yeah, so if we go to, you can again go back to the tasks and keep checking the logs, but yeah, I think we can see that it's a few things are in success and it's going on. So yeah, that I'll come back to the presentation now. So yeah, that was the end of live demo. So moving on. Just a second. Yeah, that was the live demo. Now to touch what we are working on currently. So we are actually working on some challenges with scaling. We're working with Airflow and CD. So by scaling, I mean when we are trying to run extreme load of DAGs concurrently, we want to optimize the memory and resource utilization there. Then we are trying to configure the settings right for as per the user asks, and we also want to size everything in just the right way based on the DAGs that are being submitted. And currently, we're also trying some data integrations with in-house and third-party services as well, such as Kafka, Apache Phoenix, etc. So that's about the content. I will like to. I'm open to any questions.
So this is like managed service that you're providing. Are you using Airflow for something else, like putting in the data, analytics data, or something like that?
No, we are. You mean if it's just a usage or it's a service?
Yeah, right? So I think what you showed here was the managed service that you are offering to the customers. I'm more interested in if you are using that. Let's say it's because you have cloud infrastructure, right? So you might be pulling that data and probably giving some sort of monitor report to any user. So is there any Airflow involved in that process?
So yeah, not in my team, but we have a setup in the QE where we have we are scheduling the entire pipeline where we pull the bits from release, then we build it, then we run some tests on it, and it's all linked in an upstream manner. And then eventually submit the not submit the data, eventually tell if it's a pass or a fail based on the DAG layout.
Also, I just saw the UI. So this is a different question. So in the UI you have limited amount of operators. So any reason for that? Why is there a reason why you're not supporting all the operators?
Yes, we are actually extending on that. What we are doing is in the authoring UI, we call it the authoring UI. We're keeping it minimalistic right now, but if you want to extend it beyond that and write maybe Python operator, Bash operator, etc., right? You can provide DAG files.
Okay.
This is not the only way to do it. This is one of the.
And how do you configure connections? Airflow connections.
In the UI, it's a drag and drop.
So you have to configure Airflow connections.
Connections is different.
Use certain operators, right? So is there a way for you to do that? Why like you call it?
In admin section, we can configure our console. No? We can go and create the text that connections.
I got your question. So from the UI, at least when we're just doing the linking.
So you just author the DAG and you assume the connections are already existing.
Yes, and we can go ahead and edit the configurations once you have the DAG file, right?
Okay, so connections not YAML or something like that.
Yes, not in a direct way, but you can go and edit the connection from we have the admin UI also in place.
I would like to pose this talk. We can talk.
Yeah, sure.
So I have a question. So through drag and drop, we are supporting these limited number of operators. But let's say I want to use a different operator, right? Then maybe can I write my own DAG file, import those operators, and upload it here? Or is it still even if I choose to maintain a DAG file, I am limited to these operators?
No. In a DAG file, you're not limited to these
operators. I can use my own.
You can use any
own operators. I mean, the other operators which are available.
Yeah. Apart from these 4, you can use anything extra also in the DAG file. Mm-hmm. But right now in the UI, we are
for a drag and drop. There are
limited 4.
Because of different customization, right? Each operator. So that is something we can make.
So you don't have Kafka support, right? Wherein you have a streaming thing set of data coming, and from that you try to run your Spark.
There is some work going on integrating it, but not right. You mean the data is coming from somewhere, just like an ingest? Right?
Let's say there is a different data hub altogether, wherein Kafka set of data is coming from.
So that's what he told, that we have some integration going on with third party. He told, right? Then what we are doing it right now. So that then while you are telling that upstreaming the data, we are downstreaming the data using the third party API, whether it's Kafka or Phoenix. So those things are there in the pipeline, our current upcoming roadmaps.
So extending to my question. So let's say, how do we maintain the dependency in DAG? So for example, I wrote my own custom operator and then I want to use it in my DAG file. Okay. So apart from the configuration, I also need the dependency to be installed in this particular Airflow instance, right? Mm-hmm. So how do I do that or make that operator available?
I think there are a few configurations when you're setting up your cluster. Mm-hmm. You can provide the it will be a third party, right?
It will, let's say it's a Python library.
It's a Python library, right? There is also a way to upload a Python virtual environment.
Okay.
And use it. So if you have a virtual environment where you can install your
Python library, it will be available.
Yeah, the Python libraries, link it to the DAG, and you can use it within the DAG.
So I was going through the Cloudera Airflow providers. I saw one of the sensors being there, which is a Hive sensor, partition sensor, which we are using. So did you have a look at the Hive partition async sensor also, or is it only at the sync sensor because you're blocking and worker node on your side? Or did you actually have a chance to look at the async sensor for the same one?
I'm not very sure about that because we have an Airflow team which works just through the Airflow providers. So I'll get back to you on that.
On a similar note, for the Hive, how are you setting up the connection? Because there are multiple types of connection that you can set up for the Hive, like the Kerberos authentication about username and password. Are you supporting everything for the user, or how is it done? Or let's say user wants to put a username and password, or he wants to do a Kerberos authentication or any other LDAP authentication or remote testing. How are you letting the users do it for the Hive sensor or remote Hive part?
So for the Hive part, right, we have every user is tied to a CRM. So through that you can what you can do is at least we have 2 distributions right now, public cloud and private cloud. In one of them, what we do is we generate these. If you want to go with the Kerberos model, key tab and principal, we generate a secret and we link it to the jobs. And in case of LDAP, it's again.
I was little more interested in the key tab. How are you linking with the Airflow key tab to integrate those security keys? Mm-hmm. How are you doing that? That is like one more interesting part for me. I want to know that. Meaning after the call also you can have a sync of that.
I have my teammate is on the call. Yeah.
Hey, this is Rohit. Hey, so whenever we create a virtual cluster, right, and whoever the user wants to run the job, so for him there will be a TGT generator will be associated, and for every user there will be a corresponding key tab will be generated and will be submitted via using the key tab. So CDP is fully Kerberos environment, and we always authenticated using the Kerberos only.
How do you renew the ticket? I mean, the tokens of the key tab?
Yeah, so we have internal services to do that.
Okay. So meaning with the CDP platform itself, you get that authentication.
Not the CDP platform. It is renewed by the CD services, because the once we submit any job, so it is responsible of the servers to renew it, right? If you take in the yarn, once I submit the key tab or the delegation token, the yarn is to renew it. So similarly here, we are using HDFS and also the data hub clusters, right? So
your CDC server will send those new generated key tabs to the Airflow so that you have the new key tabs generated every now and then based on the renewal timings.
not the new key tabs. We use the same key tab for one user. The token will be renewed.
Okay.
Amogh, can you share the slide deck with me, please?
I'll share it.